Hi everyone, welcome to QSO 520 Management of Spreadsheets, and today we are going to look at another example of optimization problems, and we're going to look at the real life situation. And so we will focus on make or buy decision. And so here we have an example of the ABC company, which is the leading manufacturer of computer chips. The company recently received a $750,000 order for various quantities of three types of computer chips. Each one requires a certain amount of time to design and to manufacture. The following table summarizes the requirements for the three models of computer chips. So here you can see that we have some limitations, and you can see we have three types of computer chips. And also we are having the amount of time to design and also to manufacture. That information is very important in the optimization. And so we can see the requirements here. We can see that we have those three types of computer chips. We have model 1, we have the second one, and the third, and we have some requirements. So first of all, we have number ordered. So the first model, we have 3,000 number of orders, and for the second one we have 2,000, and the third one we have 90. We have hours of designing, I'll say number of designing these items per unit. So we have 2 hours for this first model. We have 1.5 for the second, and 3 hours for the third. So that is one input or constraint, and that's for the designing. And then we have hours of manufacturing per unit. And so we can see that we have an hour to produce a unit of the first model, and we have 2 hours for the second model and 1 hour for the third model. And so it says ABC company does not have enough designing and manufacturing capacity to fill the order by its due date. The company has only 10,000 hours of designing capacity and 5,000 hours of manufacturing capacity available to devote to the order. However, the company can subcontract any portion of this order to one of its competitors. The unit cost of producing each model in-house and buying the finished products from a competitor are summarized below. So here you can see the cost to make and the cost to buy for each model. And you can see that for the first model, the cost to buy is $50 and the cost to make is $50, and the cost to buy is $61. The second one is $83 to make and $97 to buy. And for the third one, $130 to make and $145 to buy. So the company wants to determine the number of computer chips to make and the number to buy to fill the customer order at the least possible cost. So you can see that the company here is trying to minimize cost as possible. So we're going to use Excel to develop a model that will help this company make some decisions. So the first thing we're going to do in this case is to define decision variables. And so remember, our decisions are either to make or to buy, and those decisions will be for each model. And so in this case, we're going to start with module 1. And so we're going to have M1. And in this case, this shows the number of model 1 this is computer chips to make in-house. And then we can also look at module 2. And so in this case, our decision variable will be M2, and we're going to look at the number of module 2 computer chips to make in-house. And then we have module 3, and so we can define it as M3, and this will also be the number of so here we have module 2, and here we have module 3. So this is the number of module 1 computer chips to make in-house, and also for module 2 and module 3. So our decision variables to make are M1, M2, and M3. And then we're going to look at the decisions to buy, and that will be for module 1 through module 3. So I can actually copy this to module 1 to module 3, and our decisions will be to buy. So I'm going to write this B1, and we can have B1, B2, and B3. And so in this case, we're going to look at the number of module 1, not to make but to buy. And so that will be the number of module 1 computer chips to buy from competitors or from a competitor. And we can copy this to all this, and then we can change module 2, and also, that should be module 1, and that will be module 2, and that will be the number of module 3 computer chips to buy from the competitors. And so in this case, you can see that we have about 6 decision variables. The next thing is to define objective function. And so in this case, remember we are talking about this company's objective, and it is to complete the order at the least possible cost. And so in this case, we know that the company would like to minimize the cost of filling the order. So let me write here then we are going to minimize the cost of making and the cost of buying. However, we are going to look at the cost per unit. So we can see that down here we have the cost per unit to make module 1, 2, and 3. And also we have the cost to buy the unit of module 1, 2, and 3. So we are going to write this equation as minimizing 50, and that is for M1, plus 83, that is for module 2, plus 130, and that's for module 3. And then we're going to add the cost of buying, which is 61, and that is for buying a unit of module 1, and then we'll add 97, and that's the cost to buy module 2, and we have 145, and so we're going to add 145, and that is the per unit cost of buying module 3. So that is the objective function. So the next item is to define constraints. And in this case, two constraints are needed to ensure the number of computer chips made in-house does not exceed available capacity for designing and manufacturing. Let me write it. Two constraints are needed to ensure the number of computer made in-house does not exceed available capacity for designing and manufacturing. So in this case, we're going to write 2m1 plus 15m2 plus 3m3, and this should not exceed the capacity, so it should be less or equal to 10,000, and that's for the designing. And then we have 1m1 plus 2m2 plus 1m3, and that as well should be less or equal to 5,000, and that is for manufacturing. And now that's the first set of constraint right here. So let's look at the second set of constraints. So this one will be to make sure that 3,000 model 1 computer chips and 2,000 model 2 computer chips and 900 model 3 computer chips are available to fill the order. So let me write it here. Make sure that 3,000 model 1 computer chips, and then I'll write here 2,000 module 2, and so here we have 900 module 3 computer. All these are available to fill the order. That's another set of constraints. And so in this case, we can rewrite this as M1 plus B1, and that should be equal to 3,000. So that's the demand for module 1. And then we're going to have M2 plus B2, and that should be equal to 2,000, and that's the demand for module 2. And finally, we are going to have M3 plus B3 equals to 900, and that's the demand. That's the demand for module 3. And then we're going to look at the third set of objectives. And in this case, we are going to consider the non-negative values. And so in this case, we have M1, M2, M3, and then we have B1, B2, and B3. All these should be greater or equal to 0. Yes, so now you can see that we have defined our objective function, and then we have those three sets of constraints. That's the first set of constraints. That is the second set of constraints. And finally, we have the non-negative values. So after we have defined all this, the next thing we're going to do is to implement the model in Excel spreadsheet. So that should be the fourth item, right? And so in Excel spreadsheets. So let's see how we can implement the model. In this case, if you can remember, we have product, and the product here, we are looking at the number to make, and also we are looking at the number of the computer chips to buy. And here we have the computer chips. So let me create space here. So we have module 1. Let me copy this all through. We have module 1, 2, and we have module 3. And so we haven't made any decision about the number of items that we're going to make and also the number of items that we're going to buy. So in this case, we can just put zeros. So we put zeros here because we know those are the variable cells. They will vary. And so let me write here. And perhaps we can put this in a certain color. And since we're going to make certain amount of module 1, 2, and 3, and also to buy certain amount of module 1, 2, 3, we will need to see the availability. So in this case, we will look at the available and the number needed. So how do we find the available? The available will be the sum of the products that we're going to make and also to buy. So let's use the function. Here you put the sum, and that should be the sum of those two decisions, to buy or to make. And in this case, you can copy the formula across. So that will be for module 1, 2, and module 3. But we need the number of computer chips needed. And you can remember for the module 1, 3000 is needed. For module 2, 2000 is needed. And the last one will be 900. Those are the amount of computer chips needed. So we had another constraint, which is the number of hours needed. And so let's look here at the number of hours needed. And we're going to need hours to design and manufacturing. So we're going to look at designing and manufacturing. And in this case, we'll look at the number of hours needed to design module 1. And if you can remember, we need 2 hours to design module 1, and also we need an hour to manufacture that module 1. And then we have 1.5 for module 2 to design, and also we need 2 hours to manufacture that product. And finally, we have 3 hours to design. That's the module 3. And we need an hour to manufacture module 3. Then we need to find the hours used. And so in this case, we will apply the function. And here we may look at the limits. And then we will look at the available. And so let's first work on the available. We know that to design, the hours for designing is 10,000, and the number available to manufacture will be 5,000. And so how do we find the used hours? In this case, we have to apply the sum product function, and we are going to see here we have to make, not to buy. So we're going to make, and in this case we have to design and manufacture. So we can use the sum product in this case, put equal sign sum product, and that will be the sum product to design, and so put the comma sign, and it will be for the products that we're going to make, and you can close the bracket. We can look to make, so we can copy this formula to manufacturing, and therefore we can put the dollar sign. What you can do is you can put your mouse here and press F4 if you're using Windows, and I think for Mac you can use either function. Hold down function and press F4, so that the dollar sign will be also for E. And so we have locked the make, and now you can enter. And so you can copy the formula for manufacturing, and in this case we're going to manufacture the number of the chips that we're going to make, and the available hours are here. So we need to define the limits because we cannot use more than the available hours, and so in this case we have less or equal, and that will be less or equal. And in fact this one was defined here. Now the next item is to define the per unit cost, and in this case we are looking at the per unit cost to make, and also the per unit cost to buy. And so for module 1 we have $50, and just to make, and to buy is $61. For module 2 we have $83, and also we have $97, and that's to make, or I mean to buy. And then we have 130 to make, and we have 145 to buy for module 3. So in this case we will look at the per unit, the total cost, and let's put our total cost here. And to get this, just put the equal sign and use the sum product of the per unit cost to make and also to buy, and then put the comma sign. Now select the changing variables cells, And in this case, you can close the brackets and enter. So now I think we have completed creating the model in Excel spreadsheet. And so all we need to do is to apply Solver to solve this problem. You can see here we have the changing cells, or the variable cells. And also we have this, which is the set cell. And we can now implement this model by using Solver. And so that's should be the fifth item to do. Use Solver to implement the model. So in my case, I'm using Mac, so I can go to the tools and select Excel add-ins, and then I will select Solver add-in. If you're using Windows, you can add in as we learned before, and you can click OK. And then you can click on the data. Sorry, here, data, and you can see Solver. So select Solver, and now the next thing to do is to select the set objective. Here we have the set cell, which is this one. So I will click on the total cost. And remember, we're not maximizing, but we are minimizing our cost. We're not maximizing profit, or we're not even looking at the value. So we are minimizing cost, but we need to change variable. And so here we have our changing variable cells. So I will select all this changing variable cells, and that will be subject to. So we are going to add all the constraints that we mentioned earlier. So let's add one constraint after another. So the first constraint will be between the available and the amount needed. And so the amount which is available should be more than the amount which is needed. And so we'll select this, the available computer chips, and that should be greater or equal to the amount which is needed. I think we defined this earlier. And now the next one is to look at these other limits here, meaning that the used hours, or the hours that we're going to use, should be less or equal to the available hours. And so we're going to select the available hours. And finally, we are going to consider the non-negative condition. So we are going to add, and that will be all this. The amount to make and also the amount to buy should be greater or equal to 0. And I think we are done with the constraints, and so you can click OK. Make sure that make and constraint variables non-negative. We are not using GRG nonlinear, but we're using simplex linear programming. So all we can do here is just to solve. And let's see. So in this case, you can see Solver found a solution. All constraints and optimality conditions are satisfied. And in this case, I'm going to keep my Solver solution. If you didn't get all constraints and optimality conditions are satisfied, then you need to find out where the problem is and solve the problem before you proceed. You can provide the report, meaning that you can provide the answer, sensitivity, and limits, but we are not going to do that at this moment. So let me click OK. And in this case, you can see that the decision to make will be 3,000 for module 1 and 5,000 550 for module 2 and 900 for module 3. We are not going to buy anything for module 1 because we are making them in-house. But for module 2, although we will make 550, then we will need to buy 1,450. However, we don't really need to buy any of these products from the competitor. We can make the 900 for module 3. And when we do so, that means we will use less than 10,000 available hours. We're going to utilize 9,525 hours, and then we will utilize all the hours to manufacture these computer chips. And in this case, we are going to minimize our cost. And so the minimized cost will be 453,300. That is the minimum cost